Good evening, everyone. Welcome to the day 5 of ATAL Online FDP on optimizing next gen computing for smart system development. Today, Dr. Swarup Ranjan Behera sir is going to present the sessions. So, let me introduce sir to all of you. Dr. Swarup Ranjan Behera sir is an advanced data scientist at Exxon Mobil, specializing in natural language processing, speech processing, and multimodal AI. He holds a master's and PhD in natural language processing from IIT Guwahati. Previously, he was working as a senior research scientist at Reliance Geo AI, where he led a research on efficient transformer architectures and applied multimodal intelligence. His current work focuses mostly on agentic AI systems and speech AI, with several publications in top tier AI and speech conferences. Dr. Swarup sir is passionate about bridging foundational AI research with real world impact, advancing innovations at the intersection of language audio and multimodal intelligence. So now I'll request sir to start the session. Sir, over to you.
Yeah, 1 second. Thank you for the introduction. So, hello everyone. Let me share my slide and someone can just tell me if my screen is visible. 1 second. If you... let me share my screen. Yeah. Just a second. There's some issue with...
Okay, sir, no problem.
I'll rejoin. Okay. Otherwise, it is not allowing me to share my whole screen. Or let me try to share the window itself. Or let me try to share the tab. Yeah, let me know if you can see my screen.
Yes, it's visible now, sir.
Yeah, so you can see all the tabs. No, only this tab, I think. Yeah. Okay. I'll do something. Okay, I'll share my... Yeah, you can see the full screen now, right?
Yes, sir.
Yeah, so sorry for the delay. So yeah, so good evening everyone. So I'm really happy to be here for this faculty development program. So today's session I wanted to keep it a bit different. So the, as you can see from the title, it's like from transformers to agents. So rapid prototyping with pre-trained NLP models. So in this session we'll try to explore how natural language processing or text processing evolved from the traditional rule-based statistical kind of thing to the LLM thing that we are doing it now, right? Or prompting, LLM, RAG, and agentic kind of things. And I hope my voice is audible enough. Yeah. And we'll explore how these NLP involved, how the transformer paper changed everything, how we can quickly prototype these systems without months of coding that we in our masters or PhD they used to do for each model, right? So so let's begin by asking why are we here today. So I'll set the context first. Why, how NLP evolved, and why prototyping matters, and in fact what is prototyping, right? So, so why are we here, or why are we here? Why are we having this talk? Okay, so this NLP, all these models, a simple classification model used to take months and months of engineering, feature engineering, training or fine tuning, feature crafting, etc. Right, and right now the scenario has changed after transformer. Now you don't start with a blank slate anymore, meaning you start with a LLM or a model that is already trained on a huge amount of data, petabyte of data that exists on the internet. So I've written down here. So traditional LP model training used to take weeks, needs label data, you need labeler. So that is costly as well, right? Needs compute and training time as well. So now you have already have these foundation models like BERT or these new LLMs like Llama, Chat GPT, all those kind of things. So the focus is now shifted from training to prompting and data to model reuse. You don't have to again and again curate data. What I mean by data is that, let's say if we train a medical model and I cannot use it on a different domain or a machinery kind of domain, but these days you have transfer learning. If you have one model, you can just reuse it with few short fine tuning kind of thing, right? So it what it did was it really sped up the research iteration. So for us as a researcher, or you as a faculty members doing the research and recent research kind of thing, so the existing thing or the baseline, you don't have to wait or do months and months of implementation. So within a day or two you can have your baseline ready, then you can do iteration and make your new products. And literally using these new large language models, making product MVPs or POC kind of thing, these are very short duration, like in 2-3 days you can get your MVP ready and just push for production. And this has made life easy for these academic practitioners as well, right? So we'll see how the paradigm shifted in NLP. So now I'm giving you a just broader overview. After a few slides, I'll exactly show you the model changes, right? So you can see here, we started with the rule-based system. If you remember in 60s or something, the way we conversing with the chat GPT become a daily routine now, right? So the first, the chatbot kind of thing where was Eliza or something. So it was a rule-based system. So when, if any of you have coded in uh, previous generation uh, chatbot kind of thing. So there used to be rule-based system. When you just say hi, there would be a set of commands that the chatbot would reply, like hello, how are you, good morning kind of thing, right? So you have to write rules. If you just say hi, so basically you have to do intent and intent classification kind of thing from the user statement, and there are rules written where it will go and some rules will be called. So these are rule based system. Then we went to statistical methods like n-gram modeling, like bigram trigram kind of modeling, or if you have, you must have used TF-IDF and all those bag of words kind of models, where each word, for example, you have a book and you have a vocabulary, so each word will be represented using a count. Let's say in this page, this word, how many times this word occurs kind of thing. These are all statistical model. Then we moved to with the haven't with these when GPUs came, and we went to deep learning kind of thing, where we started using RNN, and then LSTM, then CNN kind of thing, right? This was the starting of the deep learning. Then came the transformer in 2017, where everything changed. So this is one of the milestone in NLP, where we moved from normal learning to transfer learning, you can say. Transfer learning meaning you train a model with a existing set of data on Wikipedia or internet. Then that model now knows the syntax and semantics of your language, for example English. Now you can train take that model, and you can train various classification model, translation model, summarization model in different domain as well, medical domain or finance domain or other domains, right? So this is called transfer learning. Then the foundation model came. So all these GPT, Llama, all this kind of thing you think, these are a bigger version of the uh, smaller this BERT and all those models, where you have the world knowledge present in these models. Like this has read your internet and everything. Now, without fine tuning or anything, you just ask it the way you use ChatGPT. What is the answer for this question, right? So it is trained on those kind of data so that it directly answer your questions. Of course, these are first these are pre-trained, then these are fine-tuned, then chat fine-tuned, instruction fine-tuned, chat fine-tuned, etc. So then we are moving towards agentic system. So agent is not much of a model, but you can think of it as a architecture where your brain is the foundation model or the LLMs or ChatGPT, for example, and you uh, uh, are organize such a system that acts the way we behave. Uh, for example, the way human thinks. So we will architect it such that using LLM, this uh, agents will think like us or mimic us. So this is the way the paradigm shift is happening in NLP from rule-based system to agentic system, right? Up to, do you have any doubts, or am I audible enough, or should I continue? Okay, I'll continue then, right? So this is the before we'll see uh, the old architecture and new architecture. Before that, I just wanted to show you what changed the field of NLP, right? So you must have heard this attention is all you need paper. This came in 2017. So basically, the authors they also didn't think that this would have such an impact, right? They were just doing it for a translation task. They're building the system for a translation task, and let's not get into the detail of attention and all, but uh, everything we are building today, the LLM or whatever your RAG on whatever generative AI things you're listening or hearing from different conferences and all those things, all those most of the things are based on this paper and this architecture, right? And because of these let's say attention or parallel attention, you can say, or contextual learning, they enabled actually the large scale pre-training and transfer learning that I was talking about. And all these transformer is the architecture behind those foundation model like GPT, and they powers everything now you use like chatbots or RAG system or agentic system as well, right? So this is the on the right I've kept the architecture. It has this left side is the encoder layer, encoder stack of encoders, and right side is the decoder, right? So and it has different components. It's not in the scope, but I'll just say that your input text when to GPT, let's say GPT is decoder only, but when we give some input to GPT, okay, write an essay about, let's say, Mahatma Gandhi. So basically the input will be first tokenized. It will the embedding will be extracted, then some positional encoding is added, because everything will go in parallel, and there is no way to get this sequential information. That's why you add positional embedding. Then this is the main part here, attention basically in a sentence. For example, a dog is walking in a road and it is wet. So what does it reflect points to, the dog or the road, right? So that's attention gives each word the importance with respect to other words, right? Then you have your feed forward neural network. So here in the encoder, your sentence input will go and your vectors of this context vector will be generated. Then it will be fed to the decoder. So here, uh, so basically all these models, generative models or GPT, this is encoder decoder, but these models, what happens is, so here from the here this context vector will go, then your cross attention will be calculated in the decoder, and let's not go into that much detail, but your linear layer and after softmax your classification probability will be there. So this is nothing but out of your vocabulary what is the most probable words, right? So when you use chat gpt, they are nothing but the next word prediction. So basically when you write essay about Mahatma Gandhi, the next word should would be out of all its vocabulary what is the most probable next word based on greedy decoding or some decoding. So it's just next word prediction, but it happens so fast that you think like it's uh, at a time it is writing the answer, right? So yeah, so that was the just about transformer. Then let's see how in old times how we used to do NLP or the modeling in NLP. So earlier these NLP model were mostly about pre-processing or feature crafting, right? So basically you can see these are the given a sentence, you have to first do tokenization. This tokenization is of course different. You just have to, based on punctuation or something or spaces, you have to uh, break the sentence, right? Then you have to do stop word removal, which is nothing but the most occurring kind of word which have no meaning, like th, the, on, this kind of thing, right? Then you have to extract feature like term frequency, inverse document frequency, later what to became as well, right? These are few feature extractors, and then you can use any classifier like super vector machine or naive Bayes or some classifier. So this is the pipeline. uh, so So here the issue was in each step you needed domain knowledge, right? And the accuracy in these older models were very dependent on how well you craft those features. So from this data set, you have to manually extract the features. So basically, there's a visual like you have data, then you and these training will be very task specific. Like you cannot once you train a classifier, you cannot use it as a summarizer or something, right? Or if you train a classifier on a one single domain, you cannot reuse it on different domain. So there is no transfer learning, right? So it works till date in industry, people use it. So it's not like you just leave it, right? When there are real-time system and sometimes feature are well crafted or easy to craft, then people still use it because these are very fast and gives good accuracy as well, right? But it's very slow to build, brittle to maintain. If new feature come, it's very hard to feature engineer it because this is all manual, right? And domain knowledge is needed. So let's say medical domain, that guy have to be expert in that domain to craft these features. So those dependencies are there, right? So I have prepared this simple demo to show you how these works, but I just have to share this tab instead. I'll just show you, not run the codes, but show you how you can how we used to do these things. So I wanted to keep it a bit code level as well so that we understand, right? So basically this is how the traditional NLP classification was. You read the data. So basically there's a few some zip file we loaded. Then you import some packages. Then you load your train files, right? Then I hope it is. Are you able to see this, or is it too small? Can I zoom in?
Yes, sir.
It's visible, right? Yeah. So this data, this task is based basically a medical abstract classification task. So you have PubMed and all those medical journals, right? They have abstract. Given the abstract, you have to find the disease categories, right? So from this abstract, the disease is eye disease kind of thing. So this is your training data. Given the abstract, find the category or classify the abstract into different categories, right? So this is training data. Then you craft a test data set as well, 80/20 or something, right? Then first you have to get inside some EDA you have to do. So first you have to clean the abstract, right? Basically you can do lowercase everything, you can remove the digits, these are not needed for a thing, then you can remove the punctuation as well, right? Then now you have clean abstract. Then you remove the duplicates rows. Then then you find out the class distribution, because you have to know that's what I'm saying, here too much of domain knowledge in terms of the medical as well as too much of machine learning knowledge is needed, okay? Because see, let's say we have 20 class and two or three classes are heavily uh, like the frequency of two and three classes are class two three classes are very high, and if you train your model in these data, then your model will be biased toward the high frequency classes, right? So you have to check the class distribution as well. So here you can see these are the high frequency classes, then it goes on decreasing. So first insight is the distribution of classes is not uniform, highly skewed. Top 7 classes had 58% of the data. So these are the 7 classes, right? So this kind of information you can get, you have to get, so that you can think on how to, while training, are you going to augment the data, uh, how you're going to solve the class imbalance problem, or how you're going to do regulation and all those things, right? So then you have to see the word distribution as well. Let's skip a bit this one. So here you can see 75% of the abstract has less than 240 words. 99% of the abstract is, basically you have to find a optimal length that captures all this abstract, right? And the longest abstract has 933 words. Most of the abstract length is between 150 to 275. So you have to find a sweet spot to cut the abstract or truncate the abstract, right? Yeah, so there's a few other things about distribution kind of thing. Then what are the number of distinct words, right? Around 2 lakhs distinct words. This is too much, we don't want that much of vocabulary. So now you find out the word frequency. So here you can see these are the stop words, the, of, and, in. So these kind of words will not contribute anything to your model, right? So 25 of the most frequent 30 words are stop words. So there's the three main challenges. Uneven class distribution, because top seven classes have 58% of the data. Then your vocab size is very high, 2 lakhs vocabulary. It should not be like that. Then your abstract length may be a problem in sequential network. So if you want to go for your LSTM and all those kind of thing, it might be an issue, right? Yeah. So yeah. So see, now you have data, you can remove stop words, you can do class imbalance, solve class imbalance using, you can augment the classes, a lower number of classes, or you can do regularization. And yeah, so first we remove the stop words. Basically you don't have to do it manually, there are packages like this, basically this WebSM. So there you have, they have a dictionary, for example, of these kind of stop words. You can just call it and remove it from your vocabulary. Then you have to lemmatization or normal this stemming kind of thing, where like go, going, gone, goes, these kind of things. So each word can have multiple forms, right? So there are various way to keep it to one word, like you can lemmatize it or stem. Okay, so that you can do. And so this is just a simple code where we are training a SVM classifier. Okay, let's not go into detail. I'm just showing you previously how many step or how much time or how much effort it used to take, and versus I'll show you now how easily you can do it, right? So now in the once your model is trained, you can predict on the test data set, and SBM gave 74% accuracy, and there are other measures as well to uh, like precision recall kind of thing. So, and this is one algorithm, SVM. So how do you select a machine learning model kind of? So there are empirically people have found out that this is kind of works mostly when numbers of samples versus number of word per sample is less than 1500. These n-gram models are better, SVM or this kind of regression kind of model. And when it is more, so then it makes sense to go for the deep learning kind of model like RNN, LSTM kind of thing, right? It's just an heuristic, you can say. People have come up with empirical findings, right? So, yeah, so that was like the LSTM. Then uh, people have that was all about the classical NLP kind of thing. Then people have when with the coming of this deep learning and all, people have moved to LSTM, then BERT based model. So I have the code. I'll share this with you so that you can go ahead and just have a look how uh, each this traditional code looks and how this LSTM code looks, how BERT based code looks, and I'll show you how we can do these using prompting as well, right? So I'll share the other tab. Yeah. So this is the old way, the whatever I shown you. That way we used to. So you've seen there are various manual process and domain knowledge needed to have this classifier ready, right? And too much of the data, the accuracy is too much dependent on the training data quality, not much on the modeling side. So then I've told you the paradigm shift was from um, rule based to from rule based or statistical to transformer based model, foundational model, then agentic. So this is one such timeline which captures what was happening in 2000. So all the statistical model we can or count based model we can call bag of words. Literally the bag of words. You have these words from this book and put it in a bag and have the count kind of thing. Just a metaphor, right? Then 2013 the what to vec came. So what was the issue with the bag of words? So these were just count of the words. So how many times a word occur in a page, right? It's nothing more, nothing less. So it didn't give any semantic meaning. So how a word is related to other word, it didn't knew. Okay, how a word like king is related to queen, or it didn't have any idea. It's just like how many times it's occurring, and that's where the count, the number was frequency was available, right? What to vec was one of the major innovation in NLP, you can say, where it bring meaning to the close by words, right? So still not fully, but the way they train and projected this word into a high dimensional space, high dimensional space, there we could found out the meaning some way, like how king is related to queen, this kind of thing, how boy is related to girl, this kind of thing, right? In a high dimensional space. So this was a big breakthrough in what to vec or NLP, you can say, because that was the first time. So in NLP, if you think one of the major big breakthrough is identifying similar word and differentiating different word kind of thing. So like the way we calculate the cosine similarity, all those kind of thing. So these are this seems very simple, but to come up with a way to identify a similar and different word is a huge thing that time. Then after what to vec, many think uh, so previously what was happening was computer vision was leading the field, right? So there is in, let's say, deep learning kind of thing, CNN and LXNet, then CNN and all this kind of thing. So computer vision was the leader in deep learning, and NLP and audio, these were following computer vision. But in 2000s, so till then what was happening is someone implemented CNN, then the NLP guys will try, can we use CNN in text? But these were not, CNN works differently. Text has different nature. Text is sequential, right? One after another, right? So it was not working well. People have made some modification to, so that CNN works with text, but with less success, let's say. Then these RNN came, right? So RNN was the first one that used to have this capture the sequential nature of the text neural network. Then RNN had some issue. Let's not go into that technical detail, but then LSTM came. So LSTM stayed for a while. So it was one of the most, till now, few people, when they, LSTM is still, people use it. So it was a very good model, right? Then it's not like the attention came in transformer paper. Before that, people were trying to bring attention to RNN and LSTM kind of thing. But in 2017, this transformer paper, those guys, the authors have shown how you can build a parallel system. So the issue with RNN was that it was sequential, so it was depending on the previous tokens, right? I am eating, so it will process I, then I am, then eating. So it was very, then it will uh, output ice cream, then it will output something. So it was very slow, and keeping the context was also very tough. When the sequence become genetic sequence become very long, how do you remember the word that was in the beginning, right? So there were various issue with RNN. Then transformer solved the thing, because it processed all this sequence in parallel. Okay, let's say 512 sequence in parallel, and there these people have showed how you can calculate attention in that parallel flow, right? So that's why it was a breakthrough. Then so transformer is a, and I'll show you the architecture. It's a encoder and decoder architecture. Encoder encodes your input, and decoder, let's say, predicts the next word kind of thing, right? So then it, uh, from that architecture, it gave rise to three different uh, architectures, sub architecture of transformer variations, you can say. One was BERT, which was encoder only. Then one was this kind of this transformer architecture, we can encoder decoder, and one was GPT, which was decoder only architecture. We'll see the whole architecture in the next slides. But most of the model you see now, that large language model, chat GPT, all these kind of models, now everything is decoder based, decoder only models, right? Those are, it started with GPT. So here you can see a 2018 BERT came. So, so these models bit vary in architecture and vary in the way these are trained. So BERT was like, it was masking. So basically, there will be a sentence: "I'm eating ice cream," so it will mask eating, right, and try to predict eating. GPT is different. GPT will try to predict next one only. So I am eating, so it will mask ice cream and try to predict that. So this is some difference in training objectives and difference in architecture. So you can see these purple colors are BERT variants of model. So BERT, digital BERT means if you have knowledge distillation kind of thing. So you have a bigger model, then they'll distill it to become a small model. Then you have Robota, a variation in similar architecture. So in 2008ish, 18, the GPT came, then GPT-2, GPT-3, and finally near the end of 2022, this Chat GPT came, which changed. Again, this was a big moment, right? Now everything became chat kind of thing. So T5, you can see these are the this follows the same architecture as transformer, the green ones. Then there a few iteration came like switch or flan T5. So it's not like only decoder only model one. So each kind of model has their own strength, right? So we'll discuss that. Yeah. I hope till now I'm uh, able to convey whatever I'm saying, right? If you have any question, we can take it. Yeah. Yeah. So I call it the transformer architecture view because from that architecture everything like popped out, right? So this is the only encoder only model. So this is the butt style model, we can say. So input is full sentence, the way I was saying. I love here. Let's say I love llamas, and outputs are embeddings only. So each word will be processed through these layers, encoder layers. When we say encoder, is not just a encoder, it's just stack of encoder. Here you can see 1 2 12. So here 12 encoders are stacked, right? And so for example, each, so here you can see this CLS. So this is a classification token. So basically it's not a part of the sentence, but the way uh, we append it at the beginning, so that when it process through all the encoder layers and at the output, these classification token will have all the information for this sentence. So these model, you can think of it as a classifier kind of model, or where from a sentence or word tokens you want embeddings, and you can use those embeddings for classification, right? So these mostly are model used. So the way these are used is you have a sentence, you use a BERT encoder kind of thing, you extract your embedding, then you fed it to your classifier. So this is the pipeline, the way it works. Or you can do name entity recognition or similarity matching kind of thing. So basically you have two sentences, you use this BERT based embedding model, you extract embedding, then you can do cosine similarity to find out which sentence are similar or not, right? So yeah, so this was encoder based model. Next is this decoder based model. So again, in the, let's not go into the detail of that encoder and decoder architecture. There is a very little, right? So these are mostly GPT style model because the GPT was the first one to model this. So input is a, for example, a sentence I love, then output is the next word. That's why it's called text generation kind of thing. So all the models we use like GPT-2, 3.5, Llama, Mistral, everything is like decoder only model. And the way told you, when you ask a question, it's not really answering. It's just finding out the next token, next token based on the probability or whatever the pattern it has seen in the data, right? So yeah, so mostly these are for, again, the way we use chat GPT, email crafting kind of thing, or text completion, rephrasing, this kind of thing. But yeah, you can say now these model have become so good in the, because of the huge training and fine tuning kind of thing. So now they can do all this kind of task as well, classification and everything, right? Here you can see masked self attention. Um, what it means is that while training, we should not we should mask the next words so that it cannot see the next word, so that it can truly predict, right? Then the third are encoder decoder model, which are called sequence to sequence model. For example, uh, you have a text and you want it to translate, like you give a English sentence and you want it to translate to German or something, right? So you have a text, your output is also a transform text, right? And here you first your English sentence will be taken, then it will fed into the encoder layers, then your context will be generated, then it will be fed to decoder, then one by one your German's tokens will be generated. So how it works is, when I say I love llamas, so now your context vector are ready, so it will be fed to decoder, then this only this first step, this will be outputted, then along all these it will be also go to the input, then how, and then these kind of words will be outputted, right? So these are mostly used for summarization and translation tasks. T5 BERT and flan T5, these are some this kind of model. So yeah, so three kind of models. One is encoder, second is decoder, and third is encoder decoder model. And you use encoder model for embedding, getting the embeddings, and use it for classification and near similarity. You use decoder only for generation. So, and most of the model we currently use in our daily life, this ChatGPT, Copilot, and all those, these are decoder based model, right? And the other set of model, encode decoder, which are good for summarization and translation. But now with too much of GPU power and data, it doesn't make that much difference, right? So this decoder only model is able to do all this kind of task. Yeah, so do you have any question till now, or we should go ahead?
No, sir. Next, please.
Ah, okay. So, so what has changed from the before transformer and after transformer, right? So earlier we used to engineer features manually. We used to engineer features, right? Now model themselves learn these features from a huge corpus of text or Wikipedia or whole of internet kind of thing, right? You have your neural network with so many parameters, billions of parameters, and they learn these features by themselves, right? And and one more thing was this pre-training, the way you used to do pre-training, it gives a universal representation of languages, and that we can take these knowledge and transfer through different tasks like classification, summarization, right? Yeah, so what I mean to say is that now you don't have to start from scratch. So you have already a big model like GPT or something, and you just tell it what to do or fine tune using few short or few examples, right? And so this is now the current workflow. You have data unsupervised, meaning you scrape data from internet, Wikipedia. Everything is text, so there is no filtering, no clearing, nothing. Just you scrape the data and keep it. Pre-training means there will be an objective like a BERT I told, mask modeling. So how these I'll just tell you how these data set training data are generated basically. So let's take one sentence, same I am eating ice cream kind of thing. So in BERT, this is called mask language modeling. So what they'll do is they'll they'll try to mask each word and try to predict that word in this sentence. For example, I am eating ice cream. I'll mask I. Now the am eating ice cream is remaining. From these, I'll try to predict I. So I'm eating ice cream as like four words, right? So just you can see in one sentence how many training data we can create. So this is one. Predicting I is one, right? Similarly, predicting M is one. Predicting eating is one. Predicting ice cream is one. So with one sentence with four words, you can have four training data. So this is called self supervised learning kind of thing, where given this text unsupervised, but you can create your training data from these unlabeled data by these kind of methods. So mass language modeling in one such method, then your next word prediction is one such method. Next word prediction meant instead of predicting masking this, what I'll do is I'll take I'll try to predict M. I'll take I'll try to predict eating. I'll take I am eating, I'll try to predict ice cream. This is called next word prediction kind of thing. These are called pre-training objectives. So you have petabyte of internet data, you do pre-training, right? Now you have a we'll analyze it like how chat gpt is made in this kind of scenario, right? So how ChatGPT is made is they've scraped all the internet data, everything, proprietary, non-proprietary. It won't matter, right? So let's take an example. How now, if you ask anything to ChatGPT to code, how it is able to code, right? So it has learned from somewhere. We used to use Stack Overflow, right? It has all the questions and solutions. So these kind of, so they have scraped everything. This Stack Overflow and all these coding websites where question, issues, and solutions are there, right? And they have trained it. First is pre-training, right? So once you train using, this is only not just coding. They have trained it coding, political, then entertainment, all this kind of, they have built a good corpus of these kind of data sets, and they've trained in all this kind of data. Now your base LLM is ready. So in ChatGPT, this will be called GPT, right? GPT model. So your GPT model is ready, which is having it's called large language model because the data is huge and your model parameters are very huge, right? So now this model is ready. You can think this model now knows all these things that it has seen, plus it knows the language, let's say English, German, uh, other language, regional language in India as well, right? And it knows the syntax of the language, how sentences are constructed, how this kind of thing. So syntax and semantic, both it knows now, but it doesn't know anything else. So it's just a model. I've told you, right? These are, let's say you train it using next word prediction. So this model can only predict the next word. Done. Done. Nothing. It cannot do anything. So now think of it like a baby. So now it doesn't know anything. So now what you, baby trying to speak few words, that's it. So now what you do is you train it to answer your question. So what is your name, this kind of thing, right? So this is called fine tuning, instruction fine tuning. You give instruction. So when a question comes, you answer it in this way. When instruction come like translate this into Spanish, so you translate it. So like that you prepare instruction fine tuning data set. When a summarization come, a paragraph come, you summarize it. So this way, this is a supervised task. So this part, second one, this is called fine tuning. So fine tuning is supervised task. So basically you have a model ready pre-trained, then you create this kind of instruction tuning sets, right? Summarization, classification, question answering, this kind of thing. This is the supervised data. This is captured by, this is of very high value. So now nowadays you can see many data companies are there, they're offering jobs, right? So for this only. So now your model knows is instruction fine tuned, meaning when you tell it answer this question, it knows what it has to speak. And when you your model get the question summarize this, it knows how summarization works. And when your model gets a translation kind of task, it knows how translation works. So now this is called fine-tuned LLM. Still, it's not your chat GPT. It's just GPT, which is instruction tuned, right? Now it knows how to answer your question or summarize or translate, but it doesn't know how to converse with you like a human, right? So that is here it is not there, but that is called chat fine-tuning. So one of the thing, have you asked yourself why these GPT and all are giving free subscription to everyone, right? So there's this saying, right? When something is free, you are the product. So basically we are giving them the data, so to train, right, for free of cost, right? So all these the way it converse with us, so it's taking the data, the way the conversation is happening, the way the flow is happening, the way the context switch is happening. For example, I'm asking some LLM based question, then the next question is what is the weather today, kind of, right? Or something, some context switch happens. So all these kind of things it is learning, and they're training. So this is called chat tune. So now your chat GPT model is ready, which can talk to you like a human. So this is the timeline, like how you have pre-training model, you have fine-tuning model, then you have chat fine-tuned kind of thing. Okay, chat model. Yeah. So next is prototyping. So why prototyping matters? So in modern LLP, speed matters, right? You test your ideas first, you get feedback, you iterate, you refine. So tools like Hugging Face or Gradio or AutoML can make this instant experimentation possible, and it these lowers the barrier for your entry to these new modern Gen AI or NLP, right? For students and researchers. So that's why it's not exactly the new research, but it's kind of a it accelerate your path to become a good. This these days you can see every day hundreds of papers are coming, right? Because of these kind of tools. So uh, let's say, for example, one paper comes, people won't take your paper seriously nowadays until you have publicized or made your models available in Hugging Face kind of thing. That's why they validate that, okay, this is like genuine results kind of thing. So I'll show you what are these tools, right, and how you can use it as a faculty member or as a researcher or as a student in your projects, papers, and teaching as well, right? So what are the key takeaways? Like, so NLP evolution we have seen from rules to statistics to deep learning to transformers, right? And the transformers changed how we learn and deploy these models. This prototyping accelerate innovation. We'll see how it will do, and I'll give you the introduction to these. Most of you know, and you must be knowing or using it in day to day. But I'll just put it everything in one place so that you can quickly build these models, right? So yeah, so first part is done. So if you guys have any question or anything, we can we can take some questions. Then we can hop into second part. Yeah. Or should I go ahead?
Yes, sir. No questions. You can.
Okay, okay, I'll start this. So now this part will be, this section or the part two will be mostly about doing how to do the projects instead of the theoretical part, right? We'll set off, see the environments, we'll see how we can access quickly 3 4 lines of code, how we can access this pre-trained model on Hugging Face, let's say. We can quickly, how 3 4 lines of code we can quickly create an UI and just send it to people. Okay, see this, I have built this translation system, right? You just see this, you can to send someone code, right? You can send someone a link to your app or something. And how you can automate the training with very low code kind of thing, like in 2 3 lines of code you can train your classifier or uh, NER system. So this talk will mostly lower the barrier to entry into NLP and modern NLP kind of research or projects, right? So yeah, so how do you choose your playground? So you must have used Google Colab in some way, right? So free GPUs, easy sharing your code and all. This is very good for demos or teaching. If you're a student or teacher who participates in this data science competition and all, Kaggle notebooks. These are very fast, reproducible, and the one difference, both are like you can say cloud notebooks. So why these are needed? Mostly in India, let's say we don't have good systems with GPUs, right? In academic institution as well or personal, it's too hard. So there are ways you don't need the systems now, right? Using a simple notebook or your iPad or even from the mobile, you can run these bigger models with few lines of code. So there are few cloud notebook providers. Notebook is nothing but instead of writing your codes in your .py file, there is a .ipynb kind of file where in the box you write these codes and you can execute. It's a kind of UI kind of thing where you can execute and see very easy, right? This is called notebook. Jupyter notebook is one such notebook, but Jupyter notebooks runs in your local, so your system has to have those specification. Or mostly in India or many places, students or us as well, we don't have access to good GPUs or high end CPUs and RAM kind of thing, right? So the good people like Google or Kaggle or Hugging Face even, so they've come up with these free GPU access and high end CPU, GPU and TPU kind of things, where you can open a session and you can just run your code there. You can save your results. But the issue with Google Colab is that your data is not non-persistent kind of thing, right? So you have to take care of, once you clean the data, you can save it in a drive or something so that next time you access it. Kaggle, I think the data is persistent, but I have to see. So I'll show you a few things using Google Colab only. So local Jupyter, you have full control, but the issue is with the GPUs. And mostly if you are coding, then you should use this VS Code. Docker is for production. It is not out of this scope, right? Yeah, so Google Colab and Kaggle, these are cloud notebooks. These are free cloud-based Jupyter environments for writing, running your Python code with the built-in support for GPUs, NLP libraries, and dataset. This is good for quick coding and all. And if you want more GPUs, just you can paying 1,000 per month. You can get high-end GPUs and more space as well. So why you use it for your NLP project prototyping and all? There's no setup required. You just click it, opens and run. We'll see how. And you have free GPU access for model testing and small scale fine tuning as well. You can share it for collaboration or teaching. These are very good for demos, tutorials, or rapid experimentation for pretend models. So we'll see one demo here, how we can use this. All of you, have you used Google Colab in some way? Nice. So anyway, I'll just give you a quick intro. So it looks like this. Each box you can have code or text, comments, for example, right? Then you run it, so it gets executed. You see the output here as well. So first thing is to connect to a runtime, right? So you should, because these are resources are very scarce, so you should not always request for GPU. So see here you can get other programming language as well, Python or Julia, or you can, if you have simple task to do, then no need to ask for GPU. You can just select CPU and run with it. TPU TPU is just Google's tensor processing unit kind of. So so you can select GPU or CPU or then save, and you can click connect. So and we'll see how this, say now is just got connected, and you can see the stats here. So you got 12.7 GB of RAM, 15 GB of RAM, GPU RAM, and 112 GB of disk. This is all free, right? This is very good for this kind of task, and you can play here, or you can do a lot of things. So if you have not done it, so and you want to start with this NLP coding or any, not only NLP, anything, deep learning based coding or anything, this is your go-to source. So we'll see the codes, but let me first tell you about Hugging Face, then we'll see. So as I've told you, if now you publish a paper and you want people to paper or run a project or something, but you want people to take you seriously or uh, find you genuine kind of thing, so you share your model. If you can share your model in these kind of places, it's a what you can say, this is a hub kind of thing. It started as a Python library offering state of the art pre-trained NLP model, for example, sentiment analysis, NER, translation summarization. So you can do just there are you can do zero shot or few shot workflows. So why this? I've been following this when it started. So they've started putting various transformer and all those kind of things. But what good thing happened was when people trained their model using this pipeline or something, they started uploading their models there. Okay, so here you can see more than 10,000, 100,000 plus models and data sets are there. So it's kind of becoming a hub kind of thing where you can just go and everything is free there. You can go there, you can select your data sets which are already cleaned and structured, any kind of data set, pre-training data set, fine-tuning data set, in any of course these are non-proprietary kind of data set, but people have with one line of code you can just call any data set and everything is there, right? So in any field, you want to do medical imaging, let's say, or medical translation, let's say, anything you want to do, all the that related data are, most of them are there, people have put it there. And people have taken these models, all these encoder based, decoder based, and encoder decoder model, they've trained this model on their data set or these data set, and they have uploaded the trained model as well in that. For example, I want to uh, have my own translation system where it translates from English to Telugu kind of thing, right? So there will be hundreds of minimum hundreds of model on English to Telugu translation there. So people have taken this translation model, trained on English to Telugu translation data sets and uploaded there. So you don't have to train it. Everything is there. You just have to go there. You just have to, I'll show you how to do it. In 2-3 lines of code, you have your own English to Telugu this pipeline ready. And what are the good things they have done is they have created very easy to use pipeline. So for example, all this process, like when you take a sentence, you need to tokenize it, then you pass it to the model, right? So everything is just one line of code, you can have everything. So they build this pipeline, you know. So literally 5-6 lines of code you can train a model, 10 lines of code you can train, deploy and do everything. And you can fine tune the model, load up. These are LLM fine tuning techniques. I will not go into it. This is very good for academic research, classroom experiments, and industry POCs as well. So we'll just see. Yeah, we'll just see quickly how we can use it. I think we have already opened it. Yeah. So let me show you how quickly you can run your code here, right? So this is the, you remember a few minutes back we have connected it. So first is you have to install. I think I can set it to presentation mode as well. So first is you have to install the transformer. This is the library, right? You can do it as well, but I want to show you this, right? So see, your transformer is installed. You have to import the transformer. How quickly? I'll show you how quickly we can have a sentiment analysis model here. These code and slides, everything I'll share it. So sir will share these with you. So I wanted to go and code this. Code, just run it to have a flavor of how these are being done, right? Here you can just in runtime, you can do run all or run before. Everything, these options are there. Then you have few tools. You can insert code cell, header, all this kind of formatting you can do. Okay. So we have installed the transformer package. We have imported the transformer package. We have imported the pipeline. I've told you they put everything on pipeline. So here, this is the important part. What so basically see. So when I say pipeline classification in one such task, so they have put what they've done is they have built a pipeline steps, for example, for classification. You don't have to now call each sentence, each module differently. You just call the pipeline and all these modules will be called simultaneously. So here you can see I've called the sentiments analysis. Sentiment analysis means given a sentence, you have to find out its positive or negative sentiment, like Amazon reviews, right? Or movie review kind of thing. So see, within few seconds, you have downloaded this model, right? Downloaded its tokenizer. This is the model, and you have printed what is the sentiment of this sentence. So this NLP workshop is excellent. So it's a good. So this is the positive. The output is positive sentiment, and score is 9. So the model is 99.98% confident that this is positive. So we'll see. We'll try a few more things. So here I'll just replace it with this NLP workshop is not excellent. Now it's negative. Uh, there are a few things you can play this with. See how fast you are getting the results. Good, not good. So within few seconds, your sentiment analysis model ready, right? Similarly, now you say classification, right? So you just have to do this pipeline zero shot classification. Then next is print zero shot. This is a lecture about deep learning. What are your classes? Actually, I'll show you like this. So zero shot, basically you have to call the pipeline here, zero shot classification pipeline. Then uh, zero shot, this is the sentence you want to classify. This is the lecture about deep learning. And this is the your levels, education, sport or technology. You can run it. See, it is downloading the model now, right? So the model is 1.63 GB. Then it will download the tokenizers as well. Then it will try to classify. So you remember, I've shown you a same classification task in the way we used to do in old time, right? Traditional NLP kind of thing. How much effort it was, like feature engineering. Then you remove the stop words, do lemmatization, small alphabet, and all those kind of things. Then you use a SVM or some model, and you get your output, right? Now it's just within a minute kind of thing. It's just loading the model, loading the tokenizer, and this is your input sentence. This is a lecture about deep learning. This is the labels or class, and this is the score. Score is basically whichever is the highest score, it will be the classes will be that one. So deep learning is about technology, right? So it has predicted well. Then you can try with few other things. So what I can do is I can just copy it, and here we have already called the model, so we can just paste paste it. Sorry. This is a lecture about sports sports fitness kind of thing, and we'll try to run it. See, now the sports is getting the highest scores, right? So it has classified it as a sports. So this is where you can play. I'll share these links so that you can go through. And same with name entity recognition. So name entity recognition, nothing but given a sentence, you have to find out the person, location, this kind of named entity, right? So here you can basically, my name is Elias and I live in New York. So it has found out New York is the location here, and Elias is the person. Somewhere it will be there, person CP. Yeah. We'll not run it because the same thing. It will run very quickly only. There is a summarization. Summarization is nothing but given a paragraph or a page, you have to summarize into one sentence kind of thing. Same thing, you can call a pipeline. And here I've given one example where you can can you hear me?
Yes, sir.
Actually, my current went. One second, give me some time. It will come in a few seconds. Yeah. Yeah, it's here. Yeah, I'm visible and audible, I hope.
Yes, sir.
Yeah. So here one change I made is in the pipeline, you can select your model as well. So here what I'm doing is for the summarization, I'm using Facebook's. See, all these big companies like Facebook, Microsoft, and Meta. Meta is Facebook, Google kind of thing. They'll also release their models so that people can use it, right? Democratize AI kind of thing. So I've used this BERT-based large CNN kind of thing model, and it is summarizing it. You can just change it and use different model, right? Then text generation. We have talked about text generation is only GPT based kind of model. So that's why I've used GPT-2 model. These are what happens is now, let's say it's GPT-4 or 5, right? So the smaller models, they'll just open source it so that people can go and experiment with these models, right? So the pipeline is text generation, model is GPT-2. So I've told you this text generation is nothing but next word prediction. So deep learning is transforming, then it will try to write a paragraph on that. I've limit the max length to 30 tokens, and I want only one sequence written. So here it has written, where is it? Yeah, this is the generated text. So deep learning is transforming the way we interact with the world. In fact, the very next step is to create own algorithm, something. So it will speak up to 30 next words, right? So this is how this text generation works. See, with 2 lines, you literally have a chat GPT to your hand, right? The things have become so easy and without any resource or nothing. You just open your browser in your mobile and your tablet or in your small spec laptop as well, and you can start doing these things. This is called inferencing. So basically, you're loading the model and calling the model to get output. This is not training. I'll show you how to do training here as well. Yeah, so we'll now go to our slide. So till now, is it clear, or if you have any doubts, we can go ahead address them.
Clear, sir.
Okay, thank you. So yeah, so now you have your, for example, you know what are the models that you want to build. You want to build a summarizer, let's say. So first, essay summarizer or something. You input a big chunk of 2 or 3 pages of text, and you want to summarize it into 2 3 sentence. Now you run your collab or something and you have your code, but you cannot send it to everyone, right? Stakeholders or someone. So now you want to make it as a with I think Yuvraj Pushpa is saying, can you demonstrate any model with image processing? Yeah, I'll give you resources where running 3 4 lines of code you can run image based yellow and all those kind of models. Okay, now I'll show you text models, but I'll give you link. I'll show you link where you can just copy that link and just copy that link and paste it on your that collab and just run any image model. So let me just complete this, then I'll show those things, right? Yeah. So now your model is ready and you are happy with your model performance, but you want the client or stakeholder to see these models, right? If you're a student, you want your prof to see these models. You can't send always the code. You have to have some UI, user interface, for this, right? And these are few tools like Gradio or Streamlit, where with 3 4 lines of code you can literally build a UI kind of thing, right? So here also in industry as well, the way we operate is client give you some task and you build a model and quickly build a UI and give them, okay, this is how the model works. Sorry. And if they are happy with the model and something, then you go on to build your professional UI. And see, these are mostly people are focused on all this machine learning kind of tasks are not too much of UI based, right? These are like mostly on performance kind of thing. So these many times these UI are also enough. And day by day, these are becoming very flexible. But I'm not saying these will serve your AI purpose, but for initial demo and all, or smaller projects, these are enough for me as well, at least. So we'll see how it works, this Gradio and all. Uh, so you remember we build a sentiment classifier, right? Now what you do is same. You install transformer. We already installed. You install this Gradio. Pip is a package manager where you can call pip install and package name and it will install. So we want to install Gradio. In instrument also we can do. Next is transformer. We import pipeline. Gradio we import it as gr. Then this is how we load sentiment analysis pipeline. Classifier pipeline, sentiment analysis. Then you have to define a prediction function. So basically what I'm doing it as, basically I'm returning the text who has the highest score, right? Then this is a simple code with one line. Gr we have imported Gradio dot interface. Then function is predict. Input is text. Output is label and uh, lunch. So what we can do is let's run it, no? So that we'll see how quickly. I think we have already imported the classifier. Okay, let me run everything. So it has installed Gradio and transformer. It is importing the pipelines and Gradio, right? You can see here. Yeah, so see, with this one line, now it has give these interface, and you can just take anything here, sentiment analysis, like this sentence we can take. Instead of showing someone the code, what you can do is you can build simple interface like this. You can enter your sentence, and not good means negative, right? Mm, Good means positive. You can have a link. So I can, that link will open a full-fledged. So this is very simple demo that I gave, like with one line. Say, you can add few lines and you can customize it, and it looks with few customization, it looks like a professional app as well, right? Again, this is for simpler tasks. So for advanced UI kind of thing, you can, and again with Copilot and all, you can now build anything. So there is nothing to be afraid of. So I'll share this notebook so you can have a look and try to execute these things, right? Yeah. So now many times people wants to get into, let's say for example, someone asks image processing. So he or she is interested in image processing, but there's this barrier, right? We all are not that much comfortable with coding, for example, at our initial stage when we are entering into this kind of domain, right? So it should not be a barrier, because with the generative AI and all, you can just ask ChatGPT to write anything, and it can write it, these codes for you, right? Which you can just execute. But there are few platform like Hugging Face is one such, where using very minimal code that is called low code kind of thing. Few lines of code you can load a model the way with 2 lines we were loading those inferencing those models, right? And few more lines, like few 7 8 more lines, or in 10 15 lines you can just literally train a model, bigger models, right? Of course the customization will be very limited. Once you want to have too much of control everything like optimization, then steps, batching, everything, then you have to go detail into the code. But what I mean to say is that it should not be a hindrance, kind of this knowing not to code or not to code efficiently should not stop you from exploring this machine learning kind of thing. So that's why people or these big companies have come up with this no code tools. So no codes means not exactly no code, but with 2 3 lines of code you can literally train these models and test them, right? So those who are hesitant to get into these kind of dom- uh, like like image processing or text processing, text classification, summarization, this kind of thing, this is a very good, these tools are very good starting point. And because you can do rapidly, you can train and see how this training works with custom data set, how you can convert your data set so that it matches their data set style, and just run it, right? So no need to manage your model architecture or tuning. So ideal for domain experts, students, or teaching these kind of models, right? So what are the key tools? So there are various different big companies have come up with different no code tools. Hugging Face Auto Train is there, right? With 3 4 lines you can just train it. Amazon Auto Gluon is there, and or Google Cloud also at ML NLP is there. Today I'll show you one such uh, tool, which is Auto Gluon from Amazon. Others are also better, but Auto Gluon I'll show you. Others you can try, right? So we'll try to see text prediction, and then semantic matching, sentence matching kind of thing. So before that, I'll show you how autogluons look like, so that uh, I'll just zoom in, right? So I'll just have a quick walkthrough, and there is a question on image processing, so I'll just point you there where you can just quickly go into it, right? So this is like no code tool from Amazon, where it's just you can do anything. Let's go to the home page. So with few lines of code, you can just like Hugging Face. What I'll do is I'll show you one example. Then I'll navigate. I'll show you where you can find other codes or models here. Okay, I have it open somewhere. Let me, 1 second. Yeah. So I'll just show you one example uh, on this one. Text prediction kind of, or text classification, sentiment analysis, and one example on sentence similarity. Uh, what my aim here is that how quickly you can train a model. Hugging Face, how quickly you can load a model. There also you can train, but I'm just giving you a few other options as well, so that you keep on exploring these. Right? So just pip install AutoGluon multimodal. Second is you import few other things. We'll do sentiment analysis training. So here I have loaded 2 such dataset. Dataset looks like this. There is a sentence, for example, very pleasing at its best moments. Level is 1, means positive. 0 means negative, hard ground, which is a negative sentiment kind of thing. This is how your training data looks like, right? Then, yeah. So training is just say this 5 line of code. you call the multimodal predictor, you get this UID, then where you want to save your model. There's a model path in temporary folder, in your current folder, in subfolder. Then this here you give the label. Label means the I'll show one second. Here the column name basically. The label column has class labels, right? So you give it, and how do you want to evaluate it? What is your evaluation metric like accuracy or F1? Here I've given accuracy. Then you pass your model path, and literally in this two line you can train your model. So predictor.fit is basically a training code. Yeah. So someone has written some function somewhere and you're just calling this function. In training data you're passing that two columns kind of thing, and time limit, you want it to run it for 1,000 seconds. Epoch option is also there, but here seconds, right? So here you can see basically it has started training model. This is the model it has loaded with 108 million parameters, and it ran for 4 epochs because 1,000 second was over there. Then now your model is trained. Next, what you do is once your model is trained, you have to evaluate your model with your test data, right? So it's just one line of code, right? Predictor.evaluate test data. So see, this becomes so easy, and your accuracy is 88.30. So this is what the no code or low code tools look like. With few lines, 4 or 5 lines, literally you can train and evaluate a model. Then you can have other accuracy scores as well, and you can see your prediction. It's slow, very slow. This is negative sentiment. It's a charming and often effective journey. It's a positive sentiment. Yeah. So next is the embedding extraction. Few things are there, but more or less these are the same thing. Instead of that, what I'll do is I'll show you. Wait a second. Yeah. So I'll show you. Someone was asking about image processing, right? I'll show that instead. So this AutoGluon, it can handle many kind of data. This is tabular data, right? So in your tables, if you have some data, if you want to infer there something, you can, here you can see. This comes under multimodal. So basically image prediction, I'll show you, or object detection, right? Image segmentation, here your codes are there. Then we did this text prediction, document prediction, semantic matching, some advanced topics. They keep on adding these things, right? But we can see one image. Yeah, this image classification we can see, or object detection also we can see. One example we can see. I'll share these links in the slides. Everything is there, right? So please go through it, whoever are interested, right? Mm, yeah, instead of running it, what we can do is we can just so image classification, let's see. First you create a image data set, load it from somewhere, right? Training data, test data kind of thing. Then but how does it look like? So what is the data? So this is the data set. Each image is a depicted clothing item, and the corresponding label is clothing category data. So basically there will be clothing item images, and you have to, these are the labels: baby pants, baby shirt, and women casual shoes, and women tops, this kind of things. These are the labels, and they'll number it 1 2 3 4, right? 0 1 2 3, let's say. And each image, this is the link of the image, has a label 0 1 2 3, I think 0 to 3, because we have 4 items. Yeah. So now your data set is ready. So in text you have sentences and labels, right? Here you'll have image links. Links means nothing but somewhere in your folder some image is stored. You give the path, okay, and the label. So this image has this cloth kind of thing. So this is how this works. So now you divide it into sorry, training and test set. Now you use same thing is same thing only. So basically you give the label and path, you give the training data, and you give the time limit. 30 seconds he is given, he or she. Then your model ran, and you have to evaluate it. So you can, from the test set, you can pass it, right? So this is how he's passing a new, he or she is passing a new image. He's displaying it for us to get a idea of what is the image. And your model is predicting, predictor dot predict, and image path, right? And it's give 0, the uh, first class, which is uh, baby pants kind of. So it's a correct things like that. You can have once again classification, object detection also you can do same thing. I think we don't have to repeat it. The idea is with few lines of code you can literally train and test your model with AutoGluon, right? So please go through it. So AutoGluon is one such library. So you have other libraries as well that you can once again you can explore. Have switch off the sharing, or let me reshare it. Yeah. So yeah, please try to explore the other tools as well. First, explore AutoGluon, I would suggest. And if ultimate thing is this Hugging Face, that, but AutoGluon will lower the bar. I hope I have shown you the image processing part. So you go through it so that it will be good. You can understand what is happening, right? And so the key takeaway from, let me share it. Yeah, so the key takeaway from this part 2 is with using this collab and Kaggle, within minutes you can get your things up. Like you can set up your whole ML environment kind of thing. With Hugging Face, you can hundred thousands, lakhs of model are there for you to experiment with. With Gradio Streamlit, you can build your UI very effortlessly. With Auto ML and all these kind of different ML solution, you can train your model without knowing coding and all. See, if you don't know these coding and all, just take these sentences, paste in Chat GPT, and ask, explain this. So this coding and all these kind of things were becomes becoming so easy to learn these days, right? You don't have to learn Python and all those things to. It's good, but it will not stop you for learning. So these days, learning, getting into new domains or coding or all these things are become very easy. The final message is you prototype, you iterate, make it better, and deploy these models, right? So next is the prompting revolution. So Sanjay, sir, should we take a 15 minutes break for the participants, or do you want me to continue? Anything is fine with me.
It's your wish, your wish, sir. I just, you can take a break or not. It's your wish.
The participants,
About it.
do they need break, or
They are giving messages. Yeah.
need need break?
Need a break.
Okay, so what is the timeline? Like 15 minutes, or
Okay, sir. 10 to 15 minutes.
okay? So I'll like rejoin, right? Or I'll be in this meeting. Okay, we'll take the break. So I'll stop sharing, but I'll continue to be in this meeting. So after 10 minutes or 8, we can start. Yeah.
Okay, sir.
Okay. Thank you. And please, if you have any question, type it in the chat so that I can address it afterwards. Yeah. Okay. Should we start it or?
Yes, sir. You can start, sir.
Okay, thank you. Yeah. So on the part one, we saw the old NLP models and how the transformer based model came and how they're changing the NLP paradigm, let's say. And the second, we saw few tools that will get you up to speed in uh, running these models, thousands of model, lakhs of model that are available, or inferencing them, then training them according to your needs. And then there's this up to chat GPT or this new last 2 years, I think there's this new kind of revolution that came, which is we can call it as prompting revolution. So what happened was previously you had to have some knowledge about modeling and other things, right? How to, even when I showed you no code, low code, all these things, still you have to know few things like where's the path of the model, where's the data, how to arrange the data set, how to train it, what is epoch, how many seconds you want to run, all this kind of thing, right? So you had to add this domain knowledge. But with this kind of model or large language models, what happened was, so prompting, we can say it's the new programming kind of thing. So there's no training, no fine tuning, just instruction. In ChatGPT, you have seen basically you can give a one pager kind of thing, and you can, sorry, ask it to summarize. It will just summarize, nothing, no calling or API or anything. So model now understand your intent from your text alone. No need to give them or fine tune them or train them, right? Because these are already instruction fine tuned to understand your text. You write behavior, you change your behavior actually. Now you write how the model should behave. So you behave like a top NLP scientist or behave like a top image processing guy, right? And write this code and write this logic or something. So you control the behavior, write the behavior, not the code. And what are the shift is fine tuning. What was happening was the effort was very high. You needed domain knowledge, and the data needed was large, and it was costly as well, right? And speed was slow because though we were seeing training can happen, but to run those training model up to a good accuracy, it takes at least 1 day kind of thing with smaller GPUs, right? So it was slow, but prompting, if I want to make you want, if I ask you to build a movie review system, if you know how to call an API and if you know how to build this Streamlit or Gradio kind of UI, with 1 hour you can, 1 hour is also too much, but let's say with 1 hour you can have a full-fledged app which works with very good quality. So the effort is very low now. There is no data needed. You just prompt it and you get your output. Cost is free. Of course, it's not that free, but yeah, still. And speed is like you just write the code, you fine tune it, refine your code. Basically, just write it, change the behavior of the model based on your code, and you can get good results. So what is prompting actually? It's just giving natural language instruction to large language models or chat GPT, Copilot to guide their behavior. But the different kind of prompts, like instruction prompt, the way I was saying, you summarize the following paragraph in one sentence. You give instruction to the model, or you ask it to classify, ask it to a question answer kind of thing. Then I'll show you a few examples. So zero shot means for example, classify this message as spam or non-spam message and you input your text. So you're not giving any example or nothing. You're just telling them, okay, this is the text. You classify into these two levels. So with zero shot means you can think zero example kind of thing, telling the model as it is to do the task. Few shot means you tell a model how it should behave. So for example, question is what is bird? The answer is a transformer encoder model. So you're telling a model to keep your answer to few words, keep it as short as possible. Otherwise, if you just write what is bird, then this chat GPT will give you 2 3 paragraphs kind of thing. So here you guided the behavior with examples. So few short means few examples, right? Then when you ask what is GPT, then it will give you a short answer. You can go and try these things in chat GPT at least, right? Then uh, these are very basic prompting, zero shot, few shot kind of thing. Then when you want to, here you can get, let's say, 60 70% accuracy, let's say. Now you want to improve your results and you don't want to fine tune something, you just want to improve your prompt. One is you assign role to your prompt. You tell it you are a top NLP expert, now tell me what is bird. Now its answer will be different, right? So you define role in prompt. You ask the system you are a helpful teaching assistant and user in asking this question, now you answer it. There are a few other ways like chain of thought prompting. So basically you make the model think before you answer kind of thing. So in the prompt you say solve this step by step. A man has 3 apples, gives one away. We'll see one example here. There's a three example of this. So this is just three. There are more advanced prompting techniques. I'll show you. So first is this zero shot prompting. Basically, you give it like this is the sentence. The movie was a total disappointment, and your levels are positive or negative. Nothing. You give nothing else to the model, and the model outputs negative. Few shot means you give few examples like classify the sentiment. Then you give few examples. When the sentence is I love this product, sentiment is positive. When the sentence is it broke on day one, the sentiment is negative. So now in addition to this sentence and all, you are giving few examples, right? Then you are asking, now the package was excellent. Now you classify this. Now model knows, it has some idea of if this kind of sentence happens, how should I classify kind of thing, right? This is called few short examples. So in the few short, it's not like you include everything because this prompt have context length. Context length meaning the number of tokens or words it can take, for example, in a rough sense, right? So, or it can input output kind of both. So let's say 10,000 is the token length. So this model in one session can do these like take or output spit out 10,000 tokens, right? So you cannot just give every examples, and it doesn't make sense also, right? Your example should guide it in a good way. Like this is a sentiment classification task and your sentiment can be positive negative, so you give 2 examples. If you have 4 classes, you can give 4 examples. If you're complex task, you can just give few edge case scenarios and all this kind of thing. So this is called few short prompting, giving examples to guide the model's behavior in your desired way kind of. Chain of thought means there's a question, a person buys 3 apple and eats one, then they buy 2 more, how many apples do they have? Think step by step. So now it will think like a reduction kind of thing. So it will think they started with 3 apples and ate one, so 2 remains. The way we teach baby this kids mathematics and all, right? We had 2 apples and we ate one, this kind of thing. So this is like chain of thought prompting. So there's this good resource where you can go and see different prompting techniques in actions. Okay. So prompt engineering guide kind of. Nowadays it became a job designation as well, prompt engineer, right? So crafting a good prompt is also of high value in the industry, because most of the companies in industry started working on APIs, right? So there are companies like Databricks and AWS and other companies, big companies. They have hosted these LLMs like ChatGPT we are using. They have hosted in their clouds these LLMs, and they'll give API. So each token cost will be there, right? So now companies, instead of training the models, they're directly using these APIs for their task, which are become is like depends on the companies, but it's making the life easier. So they don't have to hire an NLP specialist, let's say. Anyone with a basic knowledge of Python and this prompt engineering can achieve tasks up to some level, right? So which are mostly acceptable, those levels in the industry. So here just in the slide it is there. So you can just what are the other things? Yeah, you can just go here, zero shot prompting. There will be a video. Then the way I was showing this one, classify this text into negative, positive. Then if you want to see few shot, there'll be few examples, right? Or the way you want the answer. Then chain of thought, this standard prompting. So this is the in the few shot chain of thought, you ask it to, instead of just replying the answer, for example in the left, there's few shot you can say. Basically you given one example, one answer, and asking the next question, but it made the mistake. Instead of that, what you do is give the question, and the answer you show it how a human, or you will teach a kid to do it. Started with 5 balls, 2 cans of 3 tennis ball, each is 6 tennis ball, 5 + 6 11. Now the answer is 11. Then if you want, if you ask the next question, it starts to behave like that only. So it will first do step by step kind of thing instead of just spitting the answer. Then there are various advanced prompting technique. I'll not go through everything, but please, I'll share this. You can go with this. Okay. One such example is tree of thought, where it explores. Like this is just input to output, normal zero shot prompting. This one is input, then stepwise thinking output, which is chain of thought. This is self consistency. So basically, you do the chain of thought, but you run it through different stream parallelly. Then the majority output, more LLM calls, the majority output wins. And in tree of thought, you're basically it explores different options and try to converge on one options, right? Just go through it, this link, it will make more sense. Yeah, so there are various techniques here, and this web page has basically examples of prompt, like text summarization prompt, how it should look like, and how do you set your LLMs, then basics of prompting, then prompt elements, what are the different elements, instruction, ask it to summarize, context, you tell it what exactly you're trying to do, input data, give the uh, how do you pass the input data. Because see, if you're running a Excel sheet or something, each time a prompt is called, it should take few inputs rows, and each time it should populate in the prompt, right? Some loop. How do you want to do that? And how do you want to parse your output? Normal parsing, or few of the packages are there, pydentic and all, right? Few general tips for designing this prompt. So, and what are the models available, what are the risks, and what are the research findings. So this is all in all a good website to just explore. I don't know whether chart is, I don't know whether I can access it. But I'll share the slide, or you can just type prompt engineering guide and you'll get it, right? So this was about prompting like a pro. So most of the things, most of the NLP systems now, you can achieve more than 90% accuracy in these kind of NLP tasks using prompting, good prompting actually. And in the advanced systems or pipelines such as RAG or agents, uh, again these prompts are needed because everything mostly is going to be like these kind of LLMs and mostly prompt based in NLP, at least for a few years. It will be like this. So prompting is a good uh, prompting in a good way, efficient way. Everyone should learn it, right? So next, we talked about traditional NLP. We talked about modern NLP, transformer-based NLP. We talked about LLM prompting kind of thing. Finally, we'll talk about using these LLM prompting, all these things, how you can build a intelligent system instead of a single LLM, how you can orchestrate it, the intelligence like a human, how a human works, right? That is the goal of the AI, to mimic human or surpass human. So do you have any doubts or should we go ahead? I think we'll go ahead. Yeah, so we have seen how a single model inference or LLM call we can make, but it cannot be a complete solution for your project, right? So it needs LLM, you think if it like a brain, so it needs the memory, whatever happened in the past, right? So basically if I'm talking to chat GPT and yesterday I've asked it something about some disease or something or some issue that I'm having, today I don't want it to tell it again and again, right? Every day. So I want it to remember whatever I've told, and I want it to start from there, right? Like a human, if you're talking to a friend, then we'll start it where we left it, right? We'll not start everything afresh. So it needs memory, it needs retrieval, because you cannot keep everything on the memory. So you have to save many things on your database or somewhere, and when needed it should be able to retrieve, and it need tools actually. So let's say I want my agent or my system to scrape the cricket websites, let's say. So there should be a tool, web scraper kind of thing, which should go and get me those results from these websites, right? So yeah, so chat GPT, the way we use now, it became a kind of agentic, but it's not uh, the way. You cannot store everything, it's not RAG, like no database is there. But now if you see, if you're using chat GPT, you can see now it can call these tools, right? It can go and search. If you're asking what is the price of current, like uh, price of this Bangalore to Pune or some flight price, so now it has agents, it will go and search and fetch you the things. So it is improving day by day. So so basically you have to orchestrate these LLMs in some way. So basically you can make chains. So basically I have a project where I need to give a text, I need to do extraction as well and classification as well. Then you can have a chain kind of thing. So each chain, each node in this chain is like a LLM call. So given the text, first you extract few things, second you classify using those extraction results or something, right? So this is called chain, like sequential flow of prompts you can see, or sequential flow of LLM calls you can say, right? And if you have used this thing, LangChain is one such very popular library which So you can do this by yourself as well, but people like Langchen and all these people, they have written very good code where same kind of no code low code I was showing you. So people have made effort to standardize these things. You can just call their package and achieve your task, right? Or pipelines, you can say. Then router. So router is nothing but a LLM which let's say I want, the way I was giving you example, like I want cricket scraper kind of thing. So in my pipeline, whenever let's say I am asking a question ki, what is the statistic of Sachin stat of Sachin Tendulkar against Australia, let's say for example. So if I don't, my chat GPT might not have that in, it might not have trained on cricket data, right? So there will be a node where LLM, everything is LLM call. When I say node, brain, and all this kind of thing, it's just a LLM call where we are giving something to the LLM and it is taking some decision, right? It's just a prompt. You can think like that. So in that prompt, when the user say, "Give me a stat of Sachin Tendulkar against Australia," so the router is the, if you in your flow chart, it's the if else, that decision taking point only. It will see whether we have Sachin Tendulkar data. If we don't have the data, it should use some tool, scraper tool, to go to a cricket website and get these Sachin Tendulkar kind of related data. This is called task based routing. So scraping is one task, so it will go there. And if we have the data, then the router will direct the next, basically control the flow, and it will go to a extractor or parser kind of thing, right? Then graph, and graph is like conditional reasoning. Same, for example, same kind of thing. You can think, if data is present, just go with the parser. If data is not present, go with the parsing, that tool, extract scraper tool, right? LangGraph is one such framework where you can implement these things. So we'll talk not much, but two things. One, those popular things. One is RAG, retrieval augmented generation. What is RAG? Just I'll give you a glimpse of what it is. And secondly, we'll talk about a bit about agents, not to go into detail, but how you can design an agent using these LLMs, right? So why RAG is needed actually? So again, the way I told you, LLM doesn't have memory, right? And so basically, how these are trained is, let's say your recent GPT might have been trained on 2 months old data. So basically, they'll scrape all the data from internet and they'll train it. So let's say, for example, your chief minister or someone change yesterday. So if you ask chat GPT and it doesn't have access to a outside source or some database where these news are there, then it won't be able to answer you, right, correctly. It will ask 2 months back whoever was the chief minister kind of thing. So that was one example where you can use news scraper or internet tool calling in RAG. But in other things, one other example can be, you are designing a medical LLM chatbot kind of thing, where it should explain you the diseases and all, and you have a book of, let's say, 10,000 pages, multiple books, where all these diseases are well explained kind of thing, right? So now you want to store all these books in some database, right? And whenever someone asks a question about some disease, instead of answering from from the LLM alone, because LLM hallucinates. Hallucination meaning, if it doesn't know something, it will not say I don't know, it will just give you some random output, kind of a statistical parrot kind of thing, right? So to avoid these hallucination and this data shortage kind of problem, so people have come up with this retrieval augmented generation pipeline kind of thing, where what happens is, I'll show you the pipeline in the next slide. But you see, all these books you cannot directly just dump it, right? Because because I've told you this prompt have context length. It can just take some 10,000, let's say, or some tokens, right? So you cannot just give all the books to it, and because this is the database is too large, so you should give it only those section which contains disease about, let's say, dengue or malaria or cancer or anything, or cold, common cold or anything. So what you do is you chunk the document. So there is various way to chunk. So easiest way to chunk it by length. So you take 500 tokens, you chunk it. Chunk means just break it, right? You take that paragraph as one document, for example, and you take the next chunk. But this some issue with chunking. If you break it like that, the information is missed. So you can take a overlap window. It has various issue, but there are various technique for better chunking kind of thing. For example, you did this chunking. Now you cannot keep it as it is like the text in your database, because if you now want to match your query with these text database, it will take too much of time. So that's because these are text matching operation is a very lag kind of operation and compute heavy. So what you do is always this mathematics comes into play. So what you do is you convert your chunks into numbers or embeddings. Embeddings are nothing but numbers or vectors, you can say, and store it in vector database. It's kind of a database which stores vectors. So now you have, let's say, 1 lakh vectors for each paragraph. Now I ask you a question. So what is the uh, what are the medicines that I should take for common cold, right? So now my system should go and in this database find out which paragraphs talks about common cold and its remedy and all those kind of thing, right? So for example, it found out 1000 paragraphs talks about common cold in this whole R database. And top k, so now you have to select top k, because uh, you cannot just select everything. There has to be a threshold, either it's k or similarity value. Basically how they will do is, when you say find the medicines for common cold, they'll convert it to embedding as well, and they'll do this cosine similarity. And the higher the similarity score, the top are the candidates. So let's say I extract top 1000. Then there is this, I have not written it here, there is this other step called re-ranking. So out of this 1000, you'll run another small model which will re-rank them based on the similarity. So out of this 1000, 500 may be talking about common cold but not about medicines. We don't want them because our question is focused on medicine, right? So yeah, so we'll only get those paragraphs which are medicine at the top. So now you have your query and you have this top paragraphs, let's say 10 paragraphs which might contain these answer, medicine answer, and now you combine it and give it in the prompt, feed to LLM for generation. Now now the your LLM will not answer this question on its own. It will answer this question from these paragraphs. So that's how you control it to not hallucinate and all. So these are few advanced RAG techniques. For now, we'll not go through it, but you can just explore it, the self RAG and all those kind of things. This is how a simple RAG pipeline looks like. You have your book or medical documents, let's say. You split it into chunks. You extract vector embeddings from these chunks, right? You store it in a vector database. There are various vector database. So each step has some design decision that you can take when you go to production, and this is called data indexing. And second part is data retrieval and generation. So your query is nothing but give me the medicine for common cold. You do the same thing, embed it into a vector, right? Then you search it here and extract whichever chunks are more similar to this. Then you give this query and these chunks to the LLM. and then your LLM give your response. So this is the basic RAG pipeline. Now you can, after this response, you can add a validator. There are too many things you can do. Again, call the LLM, giving the question and the response. Is it the right response, kind of thing? Those things you can do, but let's not get into it. And now, second, the most everyone is now curious about these agents, right? So let's first talk about this workflows and how it is different from agent. Right? So we've talked about from chaining. So basically, it's nothing than input. You extract something, then you extract other thing, then give the output, combine and give the output, kind of thing. Multiple prompts sequentially. You can do parallelization as well. What you can do is for verification or something, same question and thing, you can ask it multiple time and get the majority voting and all. Then these are all workflow, different various workflow. So again, I'll tell you what is the difference. Then in chaining, what happens is LLM is embedded in predefined code paths. So do this, then do this. Call the LLM, call the LLM, then give the output. So here LLM directs control flow through predefined code paths. For example, this input comes. Orchestrator, the way I was saying, do we have Sachin Tendulkar data or not? If we have data, you can ask you don't have to ask the worker to collect. If you don't have, you can ask it, right? Then getting all these, do different things, extract the versus different bowlers, kind of things, spinners or pace bowlers, different workers, then synthesize the result. Then here the way I was telling, you can evaluate. Basically, you can have a input, get a output, do the evaluation here, self check kind of thing. And there is routing. Again, I was telling, if you have text cricket data, you don't have to go in this path, you go in this path, kind of thing. If else, kind of, you can just think. Agent is a bit different. Here on the left side, you have predefined the path. You have written a condition that if cricket data is not there, go in the scraper path. If cricket data is there, go in the analysis path. So these are rules are defined. Okay, predefined rules are predefined code. But in agent, LLM takes its own action based on environmental feedback. For example, here you can see, given a query, LLM will call, take an action, call and tool, and get an feedback, right? And get the output. For example, I build a ticket booking agent, right? So I'll ask it to, you know, give me the, based on the timing, weather, and price, get me a good air flight between Bangalore and Pune, for example. So normal LLM, what it will do is it will do 3 calls, weather API for next 3 days. For example, I've asked next 3 days, give me the better thing. It will do next 3 days and it will get the weather. It will do next call to a agent which get the prices, and it will get the next call to the timings, and it will get the timings, something it will do, and it will aggregate all these results, and it will just give you a solution based on the static thing. But these agent, what it will do is this tool can or when I say tool, these can be of uh, LLM calls as well, or external tools such as price fetcher kind of thing, or all this kind of thing, or weather data importer, this kind of thing. So basically, they can talk to each other and take a intelligent decision. There is this loop here, right? So whether app can give you update on, okay, this might get changed, then price it, okay, this in this time and this, yeah, the price is this. So agent can collaborate and take a decision. And we have not written any coded path like in normal chaining or uh, workflow kind of thing. You have to write a code ki if the weather is this, if price is this, and then this is this, book it kind of thing. But here agent will, based on its jurisdiction or this kind of info, it will take the action. It's scary sometimes, but in future it's going to be like that, but not in all applications. So again, agent can be of various they can have various architecture, right? So there will be one LLM. The way I was explaining this, we have a orchestrator and we have different tools, weather fetching, this fetching, price fetching, and all this kind of thing, and they will take some action. There will be multiple agent, ticket agent, weather agent, then other agent. Each agent will talk to each other, okay, and they can influence others decision as well. And there will be a supervisor, so basically there will be agent, but they'll get the info, and final, the orchestration will be done by the supervisor. There are other hierarchy and complex systems as well, right? So yeah, so I didn't wanted to put much on this because this agent is itself a different whole talk altogether, right? I just wanted to give you some direction that only one LLM call is not enough. You have to orchestrate in various way. If workflow works better for you, you can just chain it, right? Or take routing, this kind of decision. If you want a truly, see, agents, it's not that easy the way I explained. So what is a true agent? Should it be deterministic or should it be free? It can take its own decision, or when should it stop? So basically, you cannot just run an agent forever, right? This LLM calls comes with cost. So there should be a check after this much call you should stop. So if you stop that, is it a true agent? There is too much of philosophy on this kind of what is a true agent, right? So my 2 cents is, the faster you prototype, the faster you learn what matters, right? So I'll share these things. Try pipeline tonight. Share your model via a UI. Experiment more. Uh, yeah, this is, you cannot just read about things and uh, get clarity. You have to code it, or at least run those cells and see what are the things, right? So yeah, so I'll share these things. I hope I am I am able to, I did my best to convey what I wanted to say. If you have any question, I think we have time, 20 minutes. If you have any question or not technical, anything, any discussion you want to have, I would be happy to have this. Please go ahead. You don't have to be that much technical. You can just ask anything like resources or any question. There is no issue. Or any feedback, you wanted to see something different in this talk or anything, please. Free tool to visualize. These things you can ask ChatGPT and it can answer. Right. There must be something. Yeah. Any other question? Or should we stop it, ma'am?
Sir, yes, sir. It's over, sir.
Yeah, it's over.
Okay. Any questions from the participant side? I think one question is there in the chat, sir. Please check it.
Yeah, but that is like
Free
too.
agentic tools, right, for teaching purposes.
Sir, can you introduce? So yeah, so these there are basic thing whoever in the industry or academics, this line graph is the base where you should start, right? I'll share the link. Okay. Line graph just 1 second. So I'll give the rope. Basically, you can use this. Yeah, so this is a good place to start. Okay, so everyone starts with LangGraph to building their agents for bit, and so basically you can build your agent yourself with Python only. But these, as I told, these people have put effort and standardize everything so that you can just call their packages libraries and you can just it will just see these agents are nothing but you can think of them as a graph kind of thing where each node is a LLM call which takes some decisions, right? So you can do it by yourself. In Python, you can build all this by pipeline or graphs or something. But this LangGraph, they have made this node and all those classes where you can directly call and do it, right? I think we are getting few more questions. Let me see. Is it large scale training makes these models capable of performing both? In large language models, large can refer to large huge data set, okay, and of course the large scale training, meaning the number of parameters, billions of parameters, right? And huge this people are spending millions of billions of dollars in this LLM trainings. So these are very costly and compute intensive, right? Yeah, so large scale training and data.
Thank you, sir. Thank you very much.
Thank you.
Good night, sir.
Good night. Okay, bye.
Thanks to all the participants. So tomorrow we'll meet at 2 o'clock for the last day.